Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have did a numerical which was based on entropy change, and from that we have predicted whether the reaction is spontaneous or not. So let us do the third numerical of it so as to estimate whether the reaction is spontaneous or not. So for this reaction, the oxidation of iron occurs as 4 times of Fe, that gives us 3 moles, that is involved with 3 moles of oxygen, so as to provide 2 moles of Fe2O3. And in this case, the enthalpy of formation of Fe2O3 is minus 824.2 kilojoules per mole. And entropy change for the reaction is been found to be minus 549 joules per Kelvin per mole at 298 Kelvin. So in spite of negative entropy change of the reaction, as you could see that there is negative entropy change, but still the reaction will be said to be spontaneous. And why? This is the reason that we have to explain to them. So the first thing that we are going to do is we are going to do that what would be the data of this overall process or overall of the question that is provided to us. So let us calculate that thing first. So for which the given data that we have, first of all, they have mentioned that the enthalpy of the formation of Fe2O3 is been found to be that is minus 824.2 kilojoule. So therefore, since it is the enthalpy of formation, I could represent it by delta HF of, this is the heat of formation or enthalpy of the formation of Fe2O3. It has been given to be that is minus 824.2, that is kilojoule. So I will write it in the form of joule, that is 10 raised to 3 joules per mole. As well as what they have provided us is they have provided the entropy change, that is delta S. But this entropy change will be for the system because they are talking about the reaction. So therefore the entropy change that will be for the system, and in this case the entropy change of the system is been found to be that is minus 549, that is joules per Kelvin per mole. And as well as the temperature has been also been provided to us, that is temperature is equals to 298 Kelvin. But this is not simple as we are getting it, because here as we have got the value of the delta H, that is the heat of formation, but it is for only 1 mole. But what do we have? We have actually in the question that they have provided to us, they have provided us where the product is being formed 2 moles. 2 moles of Fe2O3 is been formed here. So therefore the total enthalpy now in this case would be the enthalpy of the formation of 2 moles of enthalpy would be nothing but minus 824.2 kilojoule per mole multiplied by the 2. So that will give me the heat of formation of 2 moles of Fe2O3. So we have to concern that also, because in the system 2 moles is been formed, not only 1 mole of Fe2O3 is been formed. So for that case we could write it as for 2 moles of, that is Fe2O3, therefore the delta HF, or here in this case we could say it as for system, will be nothing but minus 824.2 into 10 raised to 3 multiplied by 2. So this will be the value of the 2 moles of Fe2O3 formation, or the change that will observe in enthalpy when 2 moles of Fe2O3 has been formed. So therefore we could write this as the delta H of system that we have got will be nothing but minus 1648.4 into into 10 raised to 3, that is joules per mole. But this we can't write it for joules per mole, because the thing is it is for the system that we have got in this case. So this will be for 2 moles we have got this value. And moreover, what do we have? We have basically for system, that is the delta S of system that we have is basically minus 549 joules per Kelvin per mole. So this is what we have. So on that basis, we could estimate what would be the delta S of the surrounding. So therefore, the delta S of the surrounding, or the change in enthalpy of the change in entropy of the surrounding, will be nothing but the minus delta H of the system divided by the temperature that they have provided to us. So the temperature that they have provided to us is 298. So therefore, the delta H of the system, which was found to be basically minus 1648.4 into 10 raised to 3, the whole divided by the temperature that they have provided to us, that is 298. So on that basis, we could estimate that what would be the entropy change of the surrounding. So therefore, in this case, the change in surrounding, it will be calculated as 5.531 into 10 raised to 3. And now for the system, it was found to be joules. The unit was found to be joules, and since temperature is also been present here, so therefore joules per Kelvin. So joules per Kelvin will be for the entropy of the surrounding that we have. So now we have to calculate that in spite of having the system to be negative, that is, as you could see here, it has a negative value, but how can the reaction be spontaneous? So this can only be explained with the help of the total entropy change that we have. So therefore, we know that the total entropy change, that is delta S total, is nothing but the entropy change of the system plus the entropy change of the surrounding. So the entropy change of the system, it was been found to be, that is minus 549, that is joules per Kelvin per mole, while that of the surrounding, it was been found to be 5.531 into 10 raised to 3. So if we do this thing, then let us see what is the answer that we could get. So we have got a value of 4982.5, and again this would be basically joules per Kelvin. So this is what we have got. In this case, we could see that the value is more than 0. So therefore, since the delta S total is more than 0 or is been positive, because of which we could say that the reaction is been spontaneous process. So therefore, this makes us a clear indication that in spite of having the delta S system to be negative, but because of the delta S total is been positive, and because of this case, that is according to the second law of thermodynamics, as we have got to learn there also, that the total entropy of the total entropy will be always positive, and to make a spontaneous process. So therefore, this is nothing but a spontaneous process at a particular temperature that we have. So thank you friends for watching this video. I hope you have understood this video very clearly and you will share this video with your friends. So thank you, and please don't forget to subscribe to Ekeeda channel. Thank you so much.